Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 14, longest common prefix. This is a medium-level problem often encountered in coding interviews, and it's a great example of how to apply dynamic programming concepts. The problem statement asks us to find the longest common prefix string amongst an array of strings. That means we need to find the longest string that's a prefix of every string in the input array. For example, if we have the strings flower, flow, flight, the longest common prefix is FL. Seems simple enough, right? But there are some nuances and edge cases we need to consider. We'll explore different approaches, starting with a brute force method and then move on to a more efficient solution. Get ready to learn some awesome problem-solving techniques. Understanding with examples. Let's solidify our understanding with a few more examples. Imagine we have the strings dog, race car, car. What's the longest common prefix? Absolutely nothing. There's no common prefix among these strings. Now consider these: apple, app, appetizer. Here, the longest common prefix is app. See how the length of the common prefix can vary drastically depending on the input strings? Understanding this variability is crucial for designing an efficient algorithm. We also need to handle edge cases, like an empty input array, or an array with only one string. In those situations, what would be the longest common prefix? Exactly. For an empty array, there is no prefix, and for an array with one string, the string itself is the longest common prefix. These edge cases are important to consider when implementing our solution. Brute force approach. One naive approach would be to compare each character of the first string with the corresponding characters of all other strings. If a mismatch is found, we stop and the common prefix ends there. This is a brute force approach. We'd iterate through each string, comparing characters one by one. However, this approach isn't very efficient. Imagine having a huge number of strings, each with many characters. The time complexity becomes quite high. Specifically, in the worst-case scenario, we end up comparing every character of every string with every other string, resulting in a time complexity of O of n squared, where n is the total number of characters across all strings. While it works for smaller inputs, this brute force approach is definitely not optimal for larger data sets. It becomes computationally expensive very quickly. Optimal solution. A more efficient approach involves using a technique similar to binary search. We can compare the first characters of all strings. If they match, we continue to the next character. If they don't match, we know that's the end of the common prefix. This is much more efficient than comparing character by character in nested loops. This optimized algorithm avoids unnecessary comparisons and focuses only on the characters that are likely to be part of the common prefix. Think of it like a systematic and targeted search, rather than a blind, exhaustive search. The time complexity will reduce drastically from the O of n squared of our brute force approach to O of m times n, where m is the length of the shortest string and n is the number of strings. This means we are dramatically improving the efficiency for larger inputs. Let's see how this works in practice. Code implementation. Let's see the code in Python. We'll start by handling the base cases, empty input, or an array with only one string. Then we'll iterate through the strings, character by character, comparing them. If all characters match at a given index, we add that character to our common prefix. If there's a mismatch, we break out of the loop and return the current common prefix. It's really quite straightforward once you see the code in action. We will also use min function to find the shortest string and then iterate till its length. This way, our code will be more efficient. This keeps the code concise and easy to understand while retaining the efficiency of our algorithm. Time and space complexity. Let's analyze the time and space complexity of our optimized solution. The time complexity is O of m times n, where m is the length of the shortest string in the array and n is the number of strings. In the worst case, we might iterate through each character of the shortest string for each string in the array. Space complexity is O of 1 because we're only using a few variables to store the common prefix. We're not creating any large data structures that grow proportionally to the input size. We've significantly improved our efficiency compared to the brute force O of n squared approach. This optimized solution handles both small and large input sets gracefully, making it suitable for real-world applications. Engagement break. So, what did you think of that solution? Let me know in the comments below. And don't forget to like this video if you found it helpful. And subscribe to the channel for more LeetCode tutorials. Hit that notification bell so you don't miss out on future uploads. Also, share this video with anyone who's struggling with the longest common prefix problem. Let's help each other out and build a strong coding community. Conclusion. In this video, we've successfully tackled the longest common prefix problem on LeetCode. We explored a brute force approach and then developed a significantly more efficient solution with O of m times n time complexity. Remember,